So I'm here with Refik Anadol on the end there. And Refik is a Los Angeles-based media artist and director exploring the creative potential of machines in architecture, immersive installations, and live and audio-visual performances. And next to him is Sougwen Chung, and she's an artist and researcher based in New York. Through performance, installation, and drawing, Sougwen's speculative critical practice looks at and compares marks made by machines and people to understand the dynamics of humans and systems. And next to me is Mike Tyka. He is an artist and machine learning engineer. Tyka uses 3D printers and CAD in his sculptural practice and works with artificial neural networks to create generative works in print and other media. Please join me in welcoming our speakers. I wanted to say that given our limited time we have together, that I wanted to try and focus our discussion on some overarching issues that are important to the artists. So we're going to be talking about AI in the art world, collaboration and AI, the social impact of AI, and the environmental impact of AI. So this is sort of a question for the group. Can you guys talk about some reactions to smart technologies in the art community that you've come across?
Based on the almost like a 3 decades long art and technology, or maybe kind of mirroring that societal changes. So clearly we are seeing incredible amount of artworks and people are imagining future by using tools right now. So it's a clearly positive impact in terms of imagination.
It's quite a question. I've also been a practitioner in the space for over a decade, and I've seen technology and trends in technology kind of permeate the industries of craft and like how we talk about this type of work. I think the term smart technology is relatively more new, but I'm really encouraged and interested in how artists and people in non-technology related fields really incorporate this type of work into their existing practice, because technologies transform so many different types of industries, but it takes a lot of different types of voices to understand what that actually means and to create meaning within that space. So I get really excited by, you know, new ways of forging the two, art, technology, and science together.
Yeah, I mean, my experience has also been mostly that of excitement. A lot of people are experiencing the sort of transformations that happen through machine learning in their normal world, and so seeing that applied to art generally, I think, is exciting to people.
And given that these projects can sometimes become quite costly, what has your experience been in terms of funding or the market that's available to your work? Whoever.
So I was giving this example a lot recently. As a media artist and as a studio, we are like right now 12 people, for example. As a thinking like that, I mean, early Renaissance, for example, the artists were getting commissioned by the church or by the cities, and they were getting one of the best pigment, best brush in the world. It's not different when you have a funding from like a technology company, the best hardware, the most available algorithm. There are some similar patterns of like commissioning culture. And beyond that, I think right now the tools that a media artist may require to compute data or like train a model, this kind of like collaborations can be done by super simple in the cloud, or it's just an incredible model, let's say, that allows many artists to like create pieces in a much more, let's say, a convenient way. So I think as a studio, we are very much getting that kind of funding a lot, or commissioning art through like technology companies are very common. And it's, I think, a very significant way of like sustaining ecosystem inside the studio, purely making art, but still very connected with like tech world.
Yeah, and maybe Mike or Sougwen, can you speak to how accessible the materials are to artists who are working more in independent fields that aren't involved in public commissions or state-funded projects?
I mean, I think it really depends. I think on one hand, just the programming, you could teach yourself the stuff just with a computer. On the other hand, if you want to train your own models, that can potentially be a pretty big investment in terms of getting access to GPUs and compute power. So it sort of depends what you're trying to do. But I certainly think you can be creative even just with a laptop.
I think the question of accessibility is really contemporary and something I think about a lot these days. There's a lot of really interesting people doing work in that space. I think Daniel Schiffman's coding train is fantastic. I wish I had that when I was a younger practitioner. There's a lot of resources involved in education and making this, this dialogue with the machine and AI more accessible, more fun for different types of people, the younger generation as well. That being said, I still think there are limits to access to data and, and a lot of different other elements that could still be improved. And in my practice, I'm really interested in how to engage more types of people within the creative communities to work with AI and robotics. I have a really embodied practice where I draw with a robotic arm, and that I think helps to engage existing practices like drawing and painting within the space without needing to necessarily learn how to code or get involved with the software aspect of it.
Thank you, guys. As I was getting to know your work from afar and looking into your bios and sort of making checklists of everything that you were doing, I thought that process was really something that was at the heart of all of your work, and that the work really highlights sort of the mechanisms and component structures of the technology, whether it's the hardware or the software. And as a result, I feel like it highlights the fact that AI or smart technologies are human-made and an assembly of parts, and not sort of a discrete, authoritative thing, as sort of Sougwen mentioned in one of our conversations. And Refik, I wanted to ask you about collaboration. Can you talk about what it looks like in your studio practice? What resources, knowledge, skills, and experience have you found yourself developing or learning to execute your projects, and how has that changed over the years?
I want to give an example through a piece right now here in the art section. You will see it as a media wall that is playing two different artworks. One is called Melting Memories, and the other one is Machine Hallucinations. Like these both projects are really good examples to explain. For example, one is visualizing the moment of remembering in terms of the EEG signals. It was a true collaboration with UCSF Professor Adam Gazzaley, who is a neuroscientist and always looking for innovative way of using technology in neuroscience, also for art. So he allowed me and my team to learn how to use complex machine, which is an EEG device, and we helped them to visualize their data. And then in terms of collaboration, we witnessed that we can literally track down the moment of remembering and then transform it into an artwork. So it's a truly collaborative way of looking science, kind of architecture, and also technology to create art in the center. The other project is Machine Hallucination, which is a very very complex data set, came from NASA GPL team. It's entire photo archive of Mars surface photographed by the MRO machine, 12 terabyte of raw data of every single face of Mars, and we let AI to literally train our neural network with that data and let the AI dream surfaces that may potentially be real. So this kind of level collaborations are very common in our studio, working with different disciplines. And we have anthropologist, architect, data scientist, AI engineer, painter, sculptor, all together at the same place, horizontally thinking and imagining future. And I found it very similar to back in time, when Andy Warhol opened his factory. Is not so different than right now with technological thinking. We need more voices than I think to really navigate in this massive landscape. An African proverb, instead of if you want to go faster, you do it alone. But if you want to go further, let's do it together kind of concept. So I'm trying in the studio.
Okay. And Sougwen or Mike, can you speak to that about the collaborations in your own work and where your voice comes in the either the sculpture or the prints or the drawings that you're making?
Sure. So over the past few years, I've been developing more of a performance practice. And I've trained a robotic arm on my drawings and my own drawing style to try to embody the drawing data and the work that I've done over the past 2 decades as a drawing collaborator. I think I've been interested in doing that because I've recognized that there's a lot of interesting myths around, the machine and what it wants and what it does that are quite pervasive in this field at the moment, but what ends up happening is it ends up being mythologized in a way that I think can be a little bit dangerous. And just untrue. And part of the performance work is to sort of show not only the embodied nature of some of the data sets and the training of it, but the fallibility of it. Like it sort of changes a little bit when you see a robotic arm respond to human input in a way that speaks to like fragility and vulnerability and improvisation. And I think that's the dialogue that I get really inspired by with this new field. Not that we're building some perfect AI, but that it is really specific to the maker and the biases of the system and the one authoring it.
And with those pieces, I mean, when you look at them, do you see more of yourself or the machine in the marks? I mean, I know that it's happening at the same time, but do those marks look mechanical or do they look organic?
They're a combination, actually. So part of the project complicates this idea of authorship. And because we're working on the same canvas, it becomes the speculative object, like the point of discussion. Like, was that the human mark? Was that the machine mark? What does that mean? And I've always seen it as a microcosm for how these technologies get deployed in culture too. Like if you're writing an email and it's auto-suggesting you all these responses, which I personally hate, like, I think there's that ambiguity and that tension in just regular life too. So that's what the project aims to highlight.
Thanks. Mike, do you have any comment about the collaboration in your work or how you see sort of yourself in the work versus the data?
Yeah, so in terms of collaborating with the machine, it's definitely, if you work with any AI system, you're kind of ceding some of the control to the system. And it's not, I don't think of it as different as, for example, say splashing paint against the wall. You're kind of ceding control to the physics of paint flying through the air. Sure. And then it's an iterative process where you sort of, you respond to what happens and you tweak it and changes and the result is kind of a sort of a collaboration between, a little bit like Sougwen was talking about, between the thing you built and yourself. Mm-hmm.
Great, thank you so much. And Mike, I wanted to ask you about the social impact of AI and the, can you talk a little bit about what you've learned about the human bias built into AI from your experience using public data? I'm thinking about your portraits of imaginary people and if your perception has changed about sort of the data as objective fact.
Yeah, actually, this is a great way to understand the objectivity of data. So a machine learning algorithm is, you can think of it as a very complicated way of doing regression. You have some aim, you're trying to correlate one thing with another, you have a bunch of data, and the system is very good at picking up any correlation that it can find in order to satisfy whatever objective you're giving it. And so it is very tempting to think that because the algorithm is just a machine, it's objective, and you have the data that you collected that's clearly objective, that the results would be objective. And none of those things are really true. Data is not objective. You can get a completely different results depending on how you collect the data, who collects the data, and you have to be extraordinarily careful about not amplifying biases that are inherent in the data. I don't know exactly who came up with this phrase, but I think it really hits the nail on the head, that machine learning is like money laundering for bias. You have some biased data because all data is biased. You apply machine learning to it, and then you're like, oh, well, this is an objective algorithm. I didn't have anything to do with it. It's just that's the pattern it found. But what it's actually found is it found all the biases, and it replicates them. But now, because you're using a model rather than the real data, and you say the human is not in the loop, you say it's objective. And it's a very easy mistake to make, and its effect can be really severe on the outcome. So, and this affects all areas of AI. So we have to be very, very careful to actively identify the biases and then also sort of undo them.
So in your work, when you're sourcing, and you use data from Flickr, is that right, for the imaginary portraits? And what have you noticed about the bias in the data or the biases built by people and so on and so forth?
All the biases that people are talking about are present. I intentionally didn't try and undo them because part of my interest was to sort of visualize that fact. But you know, you find that generated women's faces smile more often than men, and this is bias that is unfortunately coming from the data, and our cultural biases that are represented in that data. And I could go on, and the list is endless. Like, it picks up everything.
But in terms of, I mean, race or ethnicity or...
I mean, the data set contains way more Caucasian people than people of color.
When it's looking for people, when you direct the algorithm to look for a certain type of person, or can you explain sort of the mechanics about it?
This particular thing is not conditional on anything. So it just, I just give it a bunch of data, and it replicates the distribution of that data as accurately as it can, and therefore it picks up all the bias.
A really good example of a project that I thought was really great that highlighted this bias was AI Now Foundation's project, I think spearheaded by Kate Crawford and Trevor Paglen, who's a photographer, but also works in this space where you just upload a photo of your face or some celebrity's face, and it sort of the AI system classifies you based on what it thinks you are. And people have been uploading their own photos, and women have a different type of classification, women of color, than men, and you can just sort of see that, how that's deployed in culture. And this is the OpenAI data set, so this is a lot of what these systems are trained on. So it's not like a proprietary data set that they're using to show this. It's sort of a really popular one that these systems are modeled on. So I would check that out if you want to, see what biases are reflected in the system.
And do you think that those biases are a product of the lack of diversity with the people who are building the systems, or do you think it's more about the data that these systems are pulling from, or is it two sides of the same coin?
I mean, just as an example to answer that, I think just recently we challenge ourselves to look at a city from a perspective of the same kind of photographic memories, and just to understand, of course, when we say the human in the centric research, the challenge is becoming much diverse. But we thought that what will happen if we literally erase the human existence from the data and just kept the architecture and urban space as an input, what will happen? And there, what we figure out that if you think about photographic memories, if you think about any urban space, let's say New York, when you have 113 million images of New York, and if you just find the people and remove them from those data set, we only left around 9.2 million images. So it's clear that this technology that we are every day using is used for more our personal, I think, recordings, let's say. And then once we have just the buildings itself, literally no human but pure building and urban space, we found that machines can recreate our memories from that perspective. So technically, I mean, and clearly, conceptually, using human-centric data eventually comes with all the complexity of human life. So it's pretty much reflecting humanity, I guess.
Wow, interesting.
But the bias can enter anywhere. So I'm pretty sure there's a correlation between socioeconomic status and the likelihood of you uploading pictures to Flickr. And so the data will reflect this. But then at the same time, people building systems, if the team of people that are building the system is not diverse, they will also not notice the biases of minorities, for example. So an example of this was just a soap dispenser that would not work for people of color because of biases presumably in the data, but also the team didn't notice this because presumably they didn't have an engineer of color who would have obviously noticed this before they launched this, and it was a disaster, right? So it pays to have the diversity at all stages of the process.
I would also add one aspect to that too, where a lot of what these systems are trained on are photographs, and the design of a camera. And the aperture and sort of light, or the perception of sight relies on certain light patterns and whatnot. So that also reflects the world and transmits data in a different way too. So it's sort of baked into the materiality of the photograph that certain hues are more difficult to capture, right? So that's not human bias, but it's just sort of thinking about what these systems are trained on, and the actual material of it plays a role in some of this as well. And I don't think it's about creating systems that can recognize faces of people of color better necessarily. I don't think that's going to create the future we want, but sort of seeing it as an ecosystem in which different parts are implicated is, I think, a useful way that I've thought about bias in machine learning.
And I wanted to shift the conversation a little bit to talk about materiality. And given that we need to use a lot of energy to obtain all this data and to process it, Sougwen, I wanted to ask you regarding the question of materiality, pollution, and AI, if you could talk a little bit about what it means for you to use personal data instead of drawing from public sources.
So I guess that's the reason I use personal data is because I'm interested in engaging with my own individual practice and how that relates to the system. But I think I read a statistic the other day that I found a little bit harrowing, which was I think the University of Minnesota trained in a natural language processing AI system, which was a rather medium. It was like medium data set, but I think it had the carbon footprint of 152 round-trip flights from New York to Beijing. And I think that's what happens when you rely on a really processor-intensive data set, essentially. The work that I do is a lot smaller, and it's about trying to find, my own personal style in the system. So it's a little bit different. Also, I try not to rely too much on the system as a generative output. I think what it does is it creates a feedback loop, a physical feedback loop in space that I don't have to constantly retrain to create new work. I think that has a better carbon footprint at the end of the day, but also helps me learn about drawing and my practice in physical space, and it's not just outputting like some image that that may or may not be like the future of the work I'm doing. So.
Sure. And Refik or Mike, do you find that, have you found any ways to sort of offset the energy consumption in your work?
Yeah, so I think in the morning there was a great analogy that human brain is around like a 10 watts when we compute our consciousness. It's pretty interesting. I mean, as an artist, I'm very inspired by dreams and memories as a whole, like discourse and context of cognitive skills of humanity. But when we think about like AI systems to simulate these artifacts, I mean, clearly we can use cloud computing, and they are clearly using, platforms using like really enormous amount of energy. So to find a solution, we have our own mini render farms and mini training server system in our studio. So at least we know how much we compute and how much power we are at least spending to like achieve a goal for artistic thinking. And we were also like trying to regulate our energy usage based on like Los Angeles and like we are like looking for the metrics in the entire city. And I'm very confident to say that we are way lower than many like people using AC in a regular time. So that's a kind of a model of like modulating our own mini ecosystem helps a lot, at least be more, I think, responsible for that.
Mike, do you have anything to add?
I mean, the brain analogy is great. There's obviously huge room for improvement, given that our brains use tens of watts max.
Mm-hmm. Yeah, definitely. Well, with the remaining time we have left, I wanted to ask you guys both about new technologies that you've been thinking about integrating into your practice, maybe even the limitations of the technology that you're already using.
I've been trying to get away from just prints with the generative work. Trying to get more into sculptural and 3D spaces.
And when you mean getting away from prints, you mean with like screens or something?
Yeah, I mean, most of the generative neural networks out there are 2D in a sense, and it's hard to move to 3D because once you move in the third dimension, then the same amount of pixels or voxels, as they're then called, now you have a much lower resolution because you're dealing with the third dimension, and so it's much more difficult to generate stuff at a high fidelity, but also it's harder to come by data. I don't have a database of 1 million sculptures or 3D objects even that's accessible to me.
Oh, interesting.
I've been experimenting more with biometrics lately, using EEG as well, and heart rate monitors as catalyst for my collaborations with the robotic arms, and also exploring multi-robotic systems as well, thinking about swarm behavior and what that looks like in performance and artifact making, but very much keeping things within the limit or the creative constraints of physical reality has been a challenge, but something that has really inspired the work. I think beyond thinking about new technologies, I've been interested in collective collaboration and what it means to create a body of work with machines, but also with different types of people as a response to some of these biases of AI and who kind of gets a seat at the table in that way. So the new work will incorporate drawing data from a large group of people in a collaborative data set that will be launched next year.
Is that going to be through sensors or some other kind of data collection?
Right now, well, there's going to be some 3D sensors with dancers, which I'm really excited about, exploring different types of Asian dance, traditional dance, as well as another project which is just going to be collaborative drawing, which is going to be tablet-based, that will input into the robotic arm.
Okay, great.
And for me in studio, we have like 3 verticals. One is like a neuroscience, where we are trying to understand memories and dreams, and to understand that we are heavily looking for neuroscientist collaborations, and clearly AI is a very significant source of inspiration. And then in robotics, we are, same to Mike's inputs, trying to like create 3-dimensional outputs from the machine's decisions, or let's say latent space, like how we can navigate a world that has n-dimensional, like how we can perceive what machine learn and how we can literally reconstruct that reality based on our human-based physical expectations. And the third one is pretty high level, but I think quantum computing is clearly one of the most exciting thing for humanity, most likely. Try to grasp, like try to understand at least, and how.
I'm sorry, could you repeat it? What was it?
Quantum computing, at least,
quantum.
how it can be applied to much major data sets. Maybe dreams and memories needs that kind of maybe computation to make the invisible more visible.
I was wondering, with your work with sort of sensing memories or recording memories, what's your experience been sort of piecing out the process of reading a memory and the other sort of sensations or reactions that are going on in a person?
If the data is really fMRI, EEG, and skin conductivity, let's say, if you have enough data to like really well recorded in terms of clinical research, it's very clear that perception and memory has a significant differences. I think we are living in a world that our memories and dreams are clearly like trying to be perceived by machines and try to like become a service, most likely. So how we can protect our most precious information in life, that it's kind of like going there, I think, the questions. But it's very clear that there's a distinct difference between memory and a perception. And I think with the more advancing technology, we will have a much more input, but I hope we can keep them private.
How do you stimulate the memory or prompt a person to have a memory?
There are multiple ways. One of our recent neuroscientists in our team from Caltech, Matt, and he's right now literally researching mostly visual stimuli. Like, for example, we are watching AI outputs. All this is a team. Like, we all like literally go through the steps, like what that specific abstraction means, what kind of like memory associations or emotional associations it's making. So we are trying to measure in-house first to at least know, can we measure it? And then we apply to a larger research, but it's still ambiguous, to be honest.
Okay, interesting. And I just wanted to close by asking you each about sort of the limitations of the technology that you're working with and your experience with sort of, I mean, one way of thinking about it would be chance, and like you're saying, if you spray some paint and what will happen that you can't predict, but instead of sort of qualifying it as an error or a glitch. But if these limitations of the medium that you're working with, whatever they are sort of a source of inspiration, or if it's a source of, if it's something to call somebody to help, an engineer or someone who can fix a problem in the machine or the software.
One limitation that you find with all generative machine learning systems right now is that they don't really generate narrative arc by themselves. It's still very much a statistical method that just tries to reproduce certain distributions. And so I think that's a huge challenge. Like, I've seen nothing even remotely being able to create a story. Even the very powerful language models. They mostly just make sure that the statistics of the words coming out make sense, but a long enough sentence won't make sense.
I think there's been a lot of, well, I don't think of them as limitations really. I've been thinking about them as catalysts and creative constraints, which I think we always have, and that's become a point of inspiration in general. There's been an interesting process of learning how the data works in the simulation on screen versus how that gets embodied in space. And some of the details of that, whether that's paint drying or an on and off button or servos heating up in general. Like there's a lot of different ways that those behaviors translated into real space are they're a really different beast. And it's been really stimulating to try to explore that, but it's also sort of gotten me down a rabbit hole of thinking about how these systems are deployed in culture. For instance, for smart cars, like they're actually not that smart, but for self-driving cars, they might work one way in the simulation, but obviously in the real world, there's a lot of different other types of inputs. So thinking about that has been part of what's driving the work.
And Refik?
I've been a little bit like more obsessed, I think, since Blade Runner, right? The movie 2019, November right now. Los Angeles is completely not there yet, but I was just dreaming about this material that can compute. And then clearly, architecture is not anymore glass, concrete, or steel. I mean, it's a physical bias of life, but I think advancement in technology may allow us to look at these materials that has this cognitive capacity of like maybe, and it's a very far distance from now, but I believe that right now, if you think the algorithm as a brush and data as a pigment, and in between we need one more layer of imagination with cognitive system, that's I'm personally like struggling, like what that can be, but I don't know that answer.
Well, thank you all so much. Thank you everybody for coming.
Thank you.
Thank you.
Thank you.